Hi everyone, this is review time again. I got this display from ICStation.com and it's a 32 by 8 red LED matrix display. And this is actually consists of 4 different displays and each of them are 8 by 8, and if I bring it a little closer you probably can see the 4 individual displays. And this display is driven by a MAX 7219 chip, which is like a serial decoder chip for LED displays. These displays are certainly not new, and I have seen these single 8x8 displays with the driver chip on the top sold as separate units, and you can get multiple of them and then have the wires coming in and then basically daisy chain them like this, which would give a sort of like a bigger display, a little bit more clumsier with the wires going back and forth. So I really like this when I saw it on ICStation's listing, that they have this module which basically 4 displays or 4 units already daisy chained together. So you can see the 5 wires going in, so VCC, ground, digital in, chip select and clock, and that basically getting linked through from the first, second, third and fourth. And actually if you buy a second unit or even a third unit, you can just put them here and then you can just daisy chain them. So you can have, actually I'm not really sure about the limit, but the library I'm using has a demo application which says that it uses 12 chips, so 12 of these 8x8 displays. So you can build a really long one. So that would be like, 3 times as long as this one. So you can fit a very long text to it. And I was amazed how easy it is to, build a project with these displays. I mean, you get this really, really cheap. It's already made. You don't really have to do anything. You get the pin headers already. So these 90-degree pin headers soldered on the right side. You actually get a second pin headers that you can put in here if you want to daisy chain something. But if you want to daisy chain a second display, probably you wouldn't use these pin headers. You would use just small jumper wires to link them through so they can touch flush to each other. And also in the with the product you get this cable, and it's ideal because you can just link it, connect it directly to a Node MCU. So I'm using a Node MCU, but I'm using the pins which are also available in a VMOS D1 Mini if you like that one better. And so it's basically just getting a Node MCU, using the wires already supplied, connect them together, and yeah, upload the program and it's running. And in fact, once I head over to the laptop, I'm going to show you that there are so many different projects around with this chipset and so many examples like YouTube counters. I even found one where it gives you like a full MQTT enabled display, so you can send MQTT messages to it and then change display settings, the speed and the intensity and everything. And what I have done here is a slightly bit different. I used one of the MAX7219 libraries, and I created a simple project which probably you can use in an automation scenario integrated with OpenHAB or I don't know, Node-RED or whatever. But it can be used as a standalone device. The ESP creates a web service. You can go to this web service. You can customize the text. You can customize the speed and the intensity of the display. So yeah, it could be great for a shop. You place them around. You can have multiples of these, and then you can just remotely change the text to whatever you need. Since I mentioned the physical form, I mean, I said that I quite really like this layout. The soldering job on this one is, yeah, it's not so great. I mean, my only criticism to this is that they couldn't really get these displays flush. So you can see, as you can see, so this one is a little bit like, maybe like a mil out to the rest. And that's because these sockets were not soldered, not pushed all the way in when it got soldered. So it's off a little bit. And then even I think this was even worse. So I had to remove the original pin and I resoldered it. So it looks, a little bit flush. Well, looks a little bit better now. And Maybe you can't see it on the camera, but in real life I can see a small line here because they are not, touching perfectly. But, from a, like a, I don't know, maybe a foot or two, it works just great. I mean, you wouldn't really notice it. And even if it's scrolling, I don't think that you can really notice it. So you can make a really nice displays out of it. And if you have one of these black film, like this is like an acrylic plate which has these sort of gray matte, well, it's not a coating, but it's just like a semi-transparent acrylic, and then you can put in front of it. I think you can even make it much nicer. I mean, it definitely looks much better on the camera if I use this in front of the display. I haven't even removed the film. So if you are planning to build a display out of it, I highly recommend to get something like this. I mentioned a couple of minutes ago that in the past there was the single units where the chip was here, and actually you had to route the cables like this. And if you find any libraries which were written to those units, those daisy chain units, you will notice that the scrolling is quite weird because it starts scrolling vertically on the first chip, and then the next one, and the third one, and the fourth, and go on. So I had to actually look around and find a different library which supports this kind of arrangement. So the way the display is oriented, it actually rotated like 90 degrees, but I guess this is how they could get the pins and everything aligned and the data lines to come through. It's not a big deal, it's just that you have to use a specific library for this, otherwise your scrolling is going to look weird. In this video I'm going to show you an Arduino Sketch, which you can download from my GitHub page. You find the link in the video description, which gives you this display. And what this display does is it connects to your home Wi-Fi, and then once it connects, then it's going to display this message: visit http://192.168.1.85 to customize, because it has started a web page where you can change the text and the speed and the intensity of the display. And by the way, I've written the code in a way that it instead of using the DHCP, it uses a fixed IP address, because, well, that would be just easier to know which IP you need to connect on, instead of this being, hopping around. But even if you choose to use DHCP, at least you can see the initial IP on the screen. So you can, well, once it boots up, you can go to that, wait for this text and go to the website and start making changes. And so, as I said, really simple. Just connect the wires to the VMOS D1 Mini, the Node MCU or VMOS D1 Mini. So I'm using pins D7, D5, and actually D4 in this particular case. And D4 is the same pin the LED is connected to, and that's why it is blinking at the moment. I am driving this display from 5 volts, so this MAX chip can work on 3.3 volts and also 5 volts. It is set to intensity 4 at the moment, so this intensity can be anything from 0 to 15. So it looks like it's running at third of the power or third of the full brightness of the LEDs. And especially now, and then because I only have like four chips, it is not consuming a huge amount of power. But if you have more, and let's say you have full intensity, and for some reason all the LEDs are lit, it can actually draw quite a bit of power. So I think somebody did a calculation that at full intensity with 8 digits, it can go up to like 4 amps. So definitely make a note of that when you are choosing the power supply. And that's one of the reasons I connected to the 5 volt pin of the Node MCU, because that 5 volt is the same 5 volt which comes from this power bank. If I had connected to the 3.3 volt, that would go through the 3.3 volt regulator on the board, which is, it's mostly designed to power the ESP. It can probably handle the extra load of the display itself, but just be aware of that you are could be overloading that voltage regulator. I mean, the best way of checking that is just to keep this display running, and then just make sure that nothing really heats up on the board. So this voltage regulators should stay, you know, just warm or just a little bit hot, and also the node MCU should stay, you know, relatively cool. First, let me take you some of the websites I was talking about. First one is the ICStation.com, and the actual product listing that I got I'm reviewing in this video is this MAX7219 Dot Matrix module, 8x32 MCU control, blah blah blah, whatever, LED module with the DuPont wires. And yeah, you can see a couple of images here, and in the product description you can see the yeah, the basics. I don't think it's anything really important here. And as you can see, there are some other modules using the same chip. So you can you can buy one single module which only has one of the 8x8 displays and one chip. You can even get it in kit form. And of course, that's not the only size of these LED matrix displays. If you shop around in AliExpress or eBay, you can probably find one which is like a much better size. Again, if you need it for a shop and you need a much better, much bigger size of matrix display, you can find those as well. And as I said, if you just Google MAX7219 ESP8266, you can find all these different projects. So as I said, a YouTube subscriber counts. Actually, there is another project which is the Wi-Fi controlled LED matrix display, similar to mine. And for example, this one is an MQTT client or MQTT controlled. So again, there are so many different examples. And if you switch to Arduino instead of ESP8266, you can probably find even more, and a lot of schematics and everything. The libraries I'm using is the MAX7219 Matrix library from Nick Gammon. And here, if you go to read more, it goes to one of his forum where he explains these matrix displays and the driver in a lot of detail. And you can get a lot of connection diagram here. As you can see, he's using Arduino for this one. And so if you're interested in the details, you can read through this. And this library also uses another library, which is called the BitBangedSPI. You need to download these two libraries, put it into your Arduino libraries folder before you can compile my project. And my project is here in my GitHub page, so I just call it MAX7219 Scroller. Again, you can find the link in the video description. My code is actually really simple. There are only just a few things that you need to modify to make it suit for your particular case. So the first thing here is you need to define the number of chips. So these are the number of 8x8 displays that are chained together. So in my example, I have 4, so I put 4. I also created a message, an internal variable to store the message, and I specified the maximum length for that, which is 500. I guess, I mean, if you want longer messages, you can increase that to, whatever number that suits you. Next, you need to specify your Wi-Fi ID, the SSID, and the Wi-Fi password. As I said, because you need to access this display via the web interface, I think it's more convenient if you can set it to a fixed IP address. So you can specify the fixed IP address here, and also the gateway, and also the subnet mask for your network. This device is not going to access the internet, so it's basically just to access its own web page. Next, in the definition, we define that we are creating this dot matrix display. We are going to call it display, the number of chips, and that's the GPIO2 pin. So that's your third connection besides D5 and D7, and so I'm using GPIO2, which in my particular case. And then you specify some of your variables, and that would be my initial message. So again, if you don't want to see this visit website something message, you can customize your own default message here, and you can also define the default scroll speed, which is actually the milliseconds between each scroll step. And also the default intensity, which I specified it to 4, which looks good enough for me. And in the setup section, I also define a serial port. So the device gives you some information what is happening on the serial. So what's this local IP address? What's the RSSI, and whenever the web page is requested, then it also prints something on the serial line. You don't really have to use it, it's only for debugging purposes. Another important one which you might need to change is this one. So again, that's where I configure the fixed IP address, the gateway, and the subnet. If you want to use the DHCP, you just comment this line out. One particular part of the setup function is these 4 lines here, where I am putting that dynamics text together, which shows the visit HTTP, IP to customize. So that's the message which is getting constructed once it manages to connect to the Wi-Fi network and it gets its local IP address. Again, if you are using fixed IP, it's not going to give you a lot of surprise what the IP is, because you just defined it. So if you want to have your own default message to come up all the time, you can comment these 4 lines out. So then this message which you have specified here will take over, and that's going to be the default message. Yeah, that's pretty much it. There is nothing else here. I have a handle main page request which puts the website together. If you want to make changes to that, you can do here. And I have a handle set command which handles all the different settings. So as we will see in the web page, you can set obviously the text, the intensity, and the delay. And these requests are handled here. And yeah, in the main loop, nothing really happens. We are checking whether we have how much time has elapsed since the last move. If it's more than the move interval, then we update the display, and the update display basically just moves the text 1 to the left, and that's pretty much it. And when it scrolls off the screen, then it goes back to the the initial one. And as you can see, scrolling the display is really easy, because this display object has a method which is called, a function which is called the send smooth. And here you specify the message, and you specify the message offset. So basically you can, by pixel, define the offset of that message. And that's pretty much it. And the library, of course, handles that if your message is longer than whatever that doesn't fit on the screen, just drops off both on the left side and the right side. So it's really easy to use. And of course, in the loop, we, besides checking the time whether we need to move the screen, we also handle the HTTP server. And that's pretty much it. So again, if you want to use this exact library or this exact example, the only really thing you need to make change here is the SSID and the password, and maybe your whatever local IP address that you prefer. Now let me go over to the website that this ESP generates, and so it's 192.168.182 with the fixed IP that I have created. And if I just refresh it, then what you see is, well, you just get this greeting message, and you have basically 3 sections. One to change the text, change the scrolling speed, and change the brightness. And of course, at the end, you get some information. What is the RSSI and what is the uptime? So this is now running for 42 minutes on that battery pack. And I can, easily change the text here. This is my new text. I've done it a couple of times. And whenever you click update, you get a message that, you get a page, the message updated, and then it automatically redirects to the initial page, and then you can see the new text scrolling. And when you change the text, the current text just disappears, and the new text starts scrolling in from the right. The next thing that you can change the speed. If you decrease the speed, it scrolls faster because the delay between 2 steps are smaller, and if you go higher, then it just becomes slower. In my experience, the delay 40 is probably the best one, because the scrolling is not too fast, so you can still read it, but still the motion appears to be fluid enough. And of course you have the brightness, the next one, so you can turn it all the way down to 1, and then again up to like 15. So again, as I said before, just be aware of the power consumption, especially if you have a really big one, and what your power supply can supply. I mean, this power bank probably can do 2 amps, so that's more than enough for these 4 chips, even on the highest intensity. But let me just go back to 4. It's not a complicated project. If you get the parts, download my sketch. You can build this in probably in 15 minutes and you will be up and running. Well, of course, you need to finish up. You need to put it into a nice case. I don't know, put it into a picture frame, get this gray or black acrylic as well to make it look really, really nice, but it's really that easy. That will be my review of this MAX7219 LED matrix display from ICStation. I hope you like this video. Thanks for watching and hopefully see you in the next video.